change the view so you can see how I'm going to see it. So, problem 2. We're going to complete these. Each of them needs a tree diagram. Now, this one is a little more complicated than the next one, but let's go ahead and do it. So, our first thing we need to do is let's just read the question. You're doing a survey, you ask 3 questions, and receive the following results. Does pineapple belong on pizza? Yes gets 45%, no gets 55%. Which do you prefer? Cats at 65% and dogs at 35%. Are you right or left-handed? Right received a percentage of 90% and left got a percentage of 10%. Now we need to make a probability tree and label each probability, then answer the following questions. Let's stop there and make our tree first. So our tree. Oops. Let's erase that and move it down. So let's make our probability tree. Our first question is, does pineapple belong on pizza? So pineapple on pizza. So, come on. Stop. Zoom out a bit. So pineapple on pizza. So I'm going to do YN, right? So I'll call this Q1. For Q1, I get Y and N. Y has a probability of 0.45. Remember, anytime you're working with probabilities, you get the percentage divided by 100, and that will give you your decimal probability. You have to use the decimal to get an answer that makes sense. Next, do Q2, which is cats or dogs. I'll use C for cat and D for dog, and C for cat and D for dog. And then here, I need to fill in their probabilities. Cat gets 65. Dog gets 0.45. Nope, 0.35, sorry. Cat again, 0.65. Dog, 0.35. Remember, they stay the same for each one. And then the last one. I then have right or left-handed. So Q3, do it for the cat first, right here. So it's right, and the rights get 90%. The lefts get 0.1%. Then for the dog, same thing. Right, 0.9. Left, 0.1. Then cat again. Right, 0.9. Left, 0.1. Then dog one more time. Right, 0.9. Left, 0.1. Okay, and we'll fill in the rest. So question 1 goes to question 2. Question 1, question 2. Okay. Now, let's answer the questions. We filled in the probability table, and we want to answer the questions. There are a few ways you can do this, and there are a few ways to make it a little bit easier on yourself. So I'm going to go ahead and, I'm just going to answer the questions. You could fill in the probabilities for each of the 8 possibilities here. I'm not going to do that. If you want to, you may, but let's just save ourselves a little bit of time. So A. My first question is this. What percentage of people like pineapple on pizza are left-handed? So we're looking for, and I'm going to go ahead, we're not going to use blue again right now. So let's use gray. So let's pick a better color. Let's pick this green color. So I'm going to go ahead and circle what we're looking for. So we want people who like pineapple on pizza, and are left-handed, regardless of if they like dogs or cats. So here, I'm going to go ahead and take the numbers that I had to travel through to get to L and multiply them together. So we'll use the white color so you can see I traveled like this, right? So I have to multiply Y, C, and L. So I get 0.45 times 0.65 times 0.1. So that's part of it. Then I have to add to it the other one. So the one that goes through the dogs and to the other left-handed. So I get 0.45 times 0.35 times 0.1. And let's go and check what those two probabilities are. So for the one that likes cats, 0.45 times 0.65 times 0.1, we get this number. So we get 0.02925 plus point. We're going to do the one for the dogs now. 0.45 times 0.35 times 0.1. We get plus 0.1575. There should be a 0 there. And let's add those together. And that should get us this number. I get 0.45. Or, oops, sorry. Keep doing that. Missing a 0. Be careful. So don't lose a 0. 0.45. And I'm not done yet. I want the percentage. So remember, this is the decimal. To find percentage, we multiply the decimal times 100. And that's going to get me 4.5%. So that's A. 4.5% like pineapple on pizza and are left-handed. Now let's do the next one. What percentage of people do not like pineapple on pizza, prefer cats, and are right-handed? So this one's much more specific. So let's use a different color. Let's use this kind of purpley color. So I travel from not liking pineapple on pizza, liking cats, to being right-handed. So we just multiply those three numbers together. So B is equal to, or not equal to, sorry. We're going to do B is 0. Where is it? We get B is 0.55 times 0.65 times 0.9. We multiply those out. I get 0.55 times 0.65 times 0.9. And I get 0.32175, which is going to get me about 32.175%, which is not the best number, but will live. And then the last one, how likely are you to meet a left-handed person who likes dogs? So we don't care particularly about the first set, but we're going to still do it. So let's go ahead and change your color one more time. Let's pick this dark blue. So we want left-handed people who are dog owners. So we're going to go from this guy to this guy to this guy, and then this guy to this guy to this guy, and I'll just draw our line going through. Okay, so C. Change the color now because you can't see it. C. We go 0.45 times, we're only looking at dogs, 0.35 times 0.1 plus 0.55 times 0.35 times 0.1. Okay. Once we check this, we get to move on. So 0.45 times 0.35 times 0.1, I get 0.01575 plus 0.55 plus 0.35 plus 0.1. Oop, I just added, sorry. 0.55 times 0.35 times 0.1. So make sure you multiply, not add. And we get 0.01925. Add those together. And we get 0.035, or that's about 3.5%. So those are your three answers. You need all three plus the tree to get your full points. And they all need to be in percentage form. If you don't have them as percentages, you're going to lose points. Okay, last one. You're doing an experiment where you roll a 4-sided die and then flip 2 coins. Make a probability tree, labeling each probability, and answer the following questions. Let's start with our probability tree. So we have a 4-sided die, so we're going to use D4. So D4, we have 1, 2, 3, 4. So that's our D4. Then we'll do with this. So this is C1, which is heads, tails, heads, tails, heads, tails, heads, tails, right? So we know each one, and then we get to do it one more time. Use this one. So C2. So we get heads, tails, heads, tails, heads, tails. Okay, let's clean this up a bit. Let's space it out a little bit more. So I'm going to zoom out more. So 1, 2, 3, 4. So you can see this is going to be a big table, or a big tree, right? So make sure you give yourself some room. C1. Get 1. No, not 1. Why am I writing 1? We get heads, tails for 1. Head. Good grief. Heads, tails for 2. Heads, tails for 3. Heads, tails for 4. And we'll go ahead, draw it out. So each of these has its first set. Now we have C3. So C3. So we get heads, tails, 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 heads, tails. And now we get to draw out the last set. So heads, tails, and so on. Once we're done with this, we get to fill in the odds of flipping each heads, tails, and each of these. So we know that for each of these, it's 0.25. It's an even dice. we know our probability, it's 0.25 for each. For the rest of these, it's 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. You get it. And then we fill in these ones. Okay, now we're done with that. Let's go ahead and answer some of the questions. So, how likely is it that you'll roll a 1 and flip 2 heads? So, we'll roll a 1 and flip 2 heads. Well, guess what? This is pretty easy to follow. So, 1 head, 2 heads. So, A, we get 1. Nope, not 1. Duh. We get 0.25 times 0.5 times 0.5. Okay, multiply it out. So we get a quarter times a half times a half. 0.5 times 0.5, 0.25. We get A is equal to 0.0625, or it's equal to about 6.25%. Then B, same problem. How likely is it that you'll roll an even number and get 1 heads and 2 tails? Okay, so we want an even number. Even numbers, you know them. It's going to be 2 and 4. So if I do 2 and 4, I need 1 heads, 1 tails. So that's going to be this one and this one. This one and this one. This one and this one. And this, whoop, caught a mistake. That was 2 heads. So you want to make sure you pick the one that is 1 heads, 1 tails. There we go. And this one. Now, we're going to use a bit of a shortcut because we actually have enough. Well, since they all have the same probability of happening, we can just multiply. So we're going to end up with 1, 2, 3, 4. So we have 4 instances. So we have 4. So 1, 2, 3, 4 circled at the very end. So I have 4 of them times the probability of one of them happening. So that's 0.25 times 0.5 times 0.5. We know that is 4 times about 6.25%. So I multiply that out. And I get about 25%. Okay. So I got 25% there. Now let's go ahead and do one more. So the last one, how likely, so I'll zoom in, how likely is it that you roll an odd number and flip 2 tails? So I want to roll either a 1 or a 3, 1 or a 3, and I'm going to flip 2 tails. So we select, so if we pick 1 and 3, travel down. There's tails, and then where does tails branch down to tails again? Right there. 3 tails here. Where does tails branch down to tails again? Right there. So how many times do I have that? So for C, I have it once, twice. So for C, I have 2 times where I roll an odd number and get tails. Now we go through, same process. We have 2 times the amount of any of the events happening. So 0.25 times 0.5 times 0.5. Fix that. 0.5. So that's the same as 2 times 6.25. And we do that again, 6.25 times 2. And that is 1/8 or 12.5%. There you go. So, big thing here. Be careful when you are setting these up. If you're given percentages like you are here, you write them with the letter you're using. So I used Y and N for no, and I used the percentages I was given here. Same thing with cat and dog. And remember, you propagate out, so you continue out with each of them. This one would be the harder one. This one's a little bit easier. You wouldn't have a tree quite this big, but you might. So make sure you read it carefully. So a 4-sided die means you have to have 4 options, 1, 2, 3, and 4. A coin is always 2-sided, so you always only have 2 options, heads or tails. And heads or tails is always going to be a 50-50 flip, right? So that is the end of probability trees. Let's go ahead. I'm going to go ahead and move on to the next topic for question 3.